Good morning, ladies and gentlemen. Welcome to Good Burger, home of the Good Burger. May I take your order? Today we're going to talk about some extensions to our Topic 7 geometry unit. We're going to extend some knowledge of triangles and introduce some things about hexagons or six-sided shapes. And I want to preface this by saying that there are other ways to solve every problem we are going to look at today, but this type of solution allows us to use what we know about triangles to solve these problems. So this first problem here, the area of a regular hexagon. Regular meaning equal sides, right, and equal angles. And so this picture here shows a regular hexagon, right? That means that every single one of these six sides has a length of 4 meters. And the steps are kind of simple when we start to think about it in terms of triangles, right? If I know this distance, right, which is the height, forgive my poor drawing, right, but it's the height of this triangle, right? I now know the base, right, is 4, and I know the height here, green was a poor choice, let's go with blue, right, the height here, this blue line down the center, is 3. So if I decompose this, right, if I break this figure into 6 triangles, every single one of these triangles is going to have a base of 4, a base of 4 and a height of 3. And so you find the area of one triangle and then multiply it by 6. So if you want to pause the screen now and try that on your own and then check your answer against mine, let's go ahead and do that. Okay. Here is the area of one triangle, right? The base is 4, the height is 3. Base times height divided by 2 got me 6 meters squared. Area is always in square units. I took 6 meters squared. I multiplied it by all 6 of the triangles. Total area in this hexagon of 36 meters squared. We can use that information to help us find the volume of a hexagonal prism. Okay, so you'll notice here that step 1 is basically what happened in the last slide. So if you felt good about doing that in the last slide, here is another regular hexagon with a base and a height, right? And I can decompose that into 6 triangles. I'm not going to draw that because it would not look good on this particular figure, but we can decompose this into 6 triangles. And if you forget about that, back up in the video and watch the last problem again. On your own, see if you can find the area of the base, right, of this regular hexagon. Do step 1. Okay, so what we have just found in step 1 is the area of this red figure, the hexagon that this figure is sitting on, right, the base. And so to do that, I took the base of 9, I multiplied it by the height of 7 8/10, and then I divided by 2 the area of one of the 6 triangles, 35 1/10 feet squared. Multiplied that by all 6 triangles. Total area of the base, 210 6/10 feet squared. Okay. Now, to find the overall volume, in step 2, right, I take the area of the base and I multiply it by the length of the whole prism, right? So this is going to kind of be like a loaf of bread. Every single one of our slices is going to be the same area of the base, and when I start to talk about how many slices are in my loaf of bread, well, that'd be 23 slices. So I take my area of my base and I multiply it by the height of the whole prism. And maybe you're following along. If you are, See if you can beat me and my calculator. I got 4,843 and 8/10 feet cubed as my final answer of the volume of this prism. All right, last problem here, looking at the volume of a triangular prism. This is going to feel very similar to the last problem, except instead of a hexagon, right, our base here is a triangle. So the steps are pretty simple. Find the area of the base of the triangle, multiply it by the length of the prism. So if you feel comfortable, try it on your own. All right, a lot of work to decipher here, right? In step one here above my squiggly line, I found the area of the base of the prism, which is a triangle. So I tried to color code this one. The base is 4, right? That's this kind of falling or sitting on the ground section. The height here in blue was 3. Before I go any further, I do want to talk about why I didn't use the 5. And if you'll recall back to topic 7, the base and the height must form a right angle. And there is no right angle given to us associated with the side that is 5 centimeters long. So I followed the formula for the area of a triangle. I found it to be 6 centimeters squared. I took that area of the triangular base, and then I multiplied it by the length of the prism shown here in green. 6 centimeters squared times 11 centimeters, 66 centimeters cubed. All right. I would like for you to work on the geometry problems and then see me with any questions. Have a great day.